This lesson is on what are called arithmetic sequences. Now, sometimes you'll hear it called arithmetic, sometimes you'll hear it called arithmetic sequences. But what they are is they are a set of numbers that go up by a constant value or go down by a constant value. We've got two objectives. You got to be able to find what we're going to call the common difference and be able to write what's called an explicit formula when you're given an arithmetic sequence. And then the second task is we're going to have to find a specific term in an arithmetic sequence. Now, the nice part about this lesson is this is stuff, guys, honestly, that a student in Algebra 1 should be able to pick up very easily because he knows how to do linear equations. All right, so in order to do an arithmetic sequence, there's a couple of things that we need to point out and make sure that we understand. I gave you this pullout right here of what a book's definition of an arithmetic sequence is. The couple of things that we got to focus on is what's called an explicit definition, which gives us this formula right here for when n is greater than or equal to 1, all right? And the other thing is a sub 1, which is also known as the initial value. We're going to call a down in that explicit formula. So these are the two main things that we're going to focus on here, all right? If a sequence is arithmetic, that means that we can find what's called a common difference. If a sequence is arithmetic, we can find what's called a common difference. We're going to refer to this as our D value, all right? So if I look at this first sequence here, all right, I notice a pattern of these numbers that from one number to the next, they continually go up by 30. Because this 30 is constant, that gives us a common difference of 30, or as I'm going to call it, a D value of 30. Okay? In this second example, I notice that the numbers go down in a pattern. They go down each time by 8 to get to the next term. This is still a common or constant difference, and our D value here would be negative 8. How about one like this? Well, it goes up by 2, then it goes up by 4, then it goes up by 8. This is not arithmetic. And we're going to find out later this week that this is actually something that is called a geometric sequence. And there are a bunch of different types of sequences, guys. We're going to focus in this week on arithmetic and geometric. All right. So how do I write an explicit formula for an arithmetic sequence? First thing I'm going to do, I'm going to find the D value, just like we did. What is the common difference? Then I'm going to substitute it into this formula. And then I'm going to simplify the formula. And what you'll see is I'm going to end up with an equation that looks very similar to slope-intercept form of a line. It's just written a little bit backwards for how you learned it. All right, so in other words, instead of it being y equals mx plus b, it's going to be more like y equals b plus mx. All right, so let's take a look here. First thing, if the sequence is arithmetic, it has a common difference. I know that my D value here is negative 200. All right. I take that negative 200, I go to the formula, and I'm going to write a sub n. That's saying a particular value at a particular position. A sub n is equal to a. Now, a is the initial value or the first term in the sequence. Negative 34 plus n minus 1. I don't know n. I don't know the position I'm going to be asked to find. Times negative 200. So all that I need to do to get this explicit formula is now clean up this right side. I have a sub n is equal to negative 34 minus 200n plus 200. Or a sub n is equal to negative 34 plus 200. That would be 166 minus 200n. This is the explicit formula. This is the common difference. Let's take a look at this second one here. I notice in this second one, this is a arithmetic because it goes up by a common difference of 100. All right, I'm going to write the equation now. A sub n is equal to a sub 1, or a, with the initial value 22, plus n minus 1 times the common difference of 100. I'm going to clean it up. A sub n is equal to 22 plus 100n minus 100, or a sub n is equal to 22 minus 100, that would be negative 78 plus 100n. This is our explicit formula. This is our common difference. I take a look at this next one. I notice that it goes up by 3. There's a common difference of 3. So my d value is 3. Okay? I'm going to say a sub n is equal to negative 6, first term, plus n minus 1 times 3, or a sub n is equal to negative 6 plus 3n minus 3, or a sub n is equal to negative 9 plus 3n. Again, this is my explicit formula. This is my common difference. All right, so this next thing, this is our last step. All right, our last objective for this is now we're going to use this same idea, but now take it one step further. We're going to create this explicit formula after we find the common difference, and then we're going to substitute in a specific value to find. This specific value to find is our n. All right, and then we're going to simplify that and see what we end up with. So what this first question is saying right here is, in this sequence, what that sub 28 right there means is, what is the 28th term? Now, there's a couple of different ways that we could do this. One way would be to write out the terms until we get to the 28th spot. That's going to take forever. A second way that we could do this is analyze what are we dealing with. I notice that this is an arithmetic sequence because there is a common difference. It goes down by 8 each time. So our common difference is negative 8. This allows me to write an equation for this, which would be a sub n is equal to negative 35 plus n minus 1 times negative 8. And then I prefer to clean it up. You could skip the cleanup step. I prefer not to. I have negative 35 minus 8n plus 8, which would be a sub n is equal to negative 27 minus 8n. This is my explicit formula. They want me to find the 28th term. I know that that 28th term, or a sub 28, can be found by taking negative 27 minus 8 times 28. All right? From here, I'm going to grab a calculator and have the calculator help me do the work now. So I have negative 27 minus 8 times 28, which tells me the 28th term was negative 251. If I were to continue this sequence of numbers, this negative 35, negative 43, negative 51, negative 59, the 28th spot in that sequence would be negative 251. All right? This technique that I'm showing you right here, by using a common difference in the explicit formula, make this a whole lot easier. All right? Let's try one more. Now notice on this one, I have a common difference of 6. So I'm going to write my equation that says a sub n is equal to the initial values, negative 7, plus n minus 1 times the common difference, or 6. Again, I like to clean it up. Negative 7 plus 6n minus 6, or a sub n is equal to negative 13 plus 6n. I'm now going to worry about finding the 23rd position. Why? Because that's what they are asking for. So the 23rd term would be negative 13 plus 6 times 23. Grab my calculator. Negative 13 plus 6 times 23. And I get that the 23rd term is 125. I hope this helps. Good luck. Let me know if you have any questions.